So welcome to the course on electrical and hybrid vehicles. Okay. So this is the first time university has offered this course to the 7 semester students. Okay. And as we know, the vehicle is an unavoidable machine for the industry, individual, or for government, right? And the fuel consumptions have led the nations to be dependent on electric vehicles and needs a major change in the operation in context to saving the energy. Okay? So these electric vehicles has drawn attentions of the designers, researchers, and manufacturers for the skilled persons needed in this particular era. Okay? And the energy saving concept has led to hybrid electric vehicles in all the concepts of the transportation. Okay? So this basically is a 3 lecture, 0 tutorial and 0 practical offering 3 credit from the course, right? And talking about the examination schemes, we will be having one end semester examination of 70 marks and one progressive assessment, which is your continuous evaluation exam of 30 marks. Okay, there won't be any viva or any practicals for this particular subject as of now. Okay, so total 100 mark subject is there, which contains only theory, right? And talking about the content to be covered in this particular course, so we have divided the entire syllabus into six different modules. Okay, so we will deal with the introduction to electric vehicle in the first module. Introduction to electric vehicle, right? This will be our first module. Then similarly, as we have discussed that the hybrid electrical vehicles are most famous nowadays. Okay, so we'll also see the introduction and some will go into the depth of these hybrid electric vehicles, which are famously known as HEVs. Okay, we'll see what do you mean by these hybrid electric vehicles as we move on. And then whether we are dealing with electric vehicles or hybrid electric vehicles, we require the drivetrains. Okay, so we will try to introduce you with the different drivetrains, which is your electric drive trains, right? You already have gone through the electrical drive subject. Okay, so we will look into the deeper side of these drivetrains. Then the most important part of electric vehicle is the battery, right? So what are the storage systems available for our electrical vehicle, right? So we will see each and every type of storage systems available to us and what are the new areas in which the research is going on for finding out these types of storage system. Okay, so this particular modules will cover the basics of hybrid and electrical vehicles, right? And then we'll move on to the modeling of this hybrid electrical vehicle range. Okay, we'll try to model some vehicles. Okay, so modeling of hybrid electric vehicles. What do you mean by modeling? We will see some driving cycles, we'll see the types of driving cycle, then range modeling for some battery electric vehicle, right? Whatever say fuel cell electric vehicles are also available, solar powered vehicles are also available, and we will see, we'll study some case study for this two wheelers, three wheelers, and four wheelers, which are available across the globe, right? So our fifth module would be modeling of electric vehicle range, hybrid electric vehicle range. And then in the final module of the course, we will see some introduction to energy management strategies. This is also the most important thing because whatever energy we are using in the batteries, we should utilize each and every inch of that particular energy. Okay, so we will be seeing some strategies which are used in these hybrid and electric vehicles. If we will classify if there are any, and then we will try to compare these different energy management strategies as well as implementation issues of these strategies. Okay, what are the various challenges as of now into the market to implement these particular strategies. Okay, so we'll be dealing with these 6 modules in our entire course. Okay, so we'll have 3 lectures per week in this particular course, and today we are going to start with the introduction to electric vehicle, right? So before we start with the electric vehicle, actually, let us understand why we require this electric vehicle. Okay, as of now, you know, we are available with the internal combustion engines, right? IC engines everywhere. Okay, and they are also quite cheap. You know, we don't have to invest much in this particular kind of vehicles. Still, we have to move forward, and we try to find a new way of transportation, because transportation is very much important for any country, whether it is a developing country or already developed country. Transportation is a must. Okay, and we know about the development of internal combustion engine vehicles, right? Especially automobile vehicles, right? It is one of the greatest achievement of modern technology, right? Automobiles have made great contributions to the growth of modern society by satisfying many of its needs for mobility in everyday life, right? The rapid development of the automotive industry, unlike that of any other industry, has prompted the progress of human society from a primitive one to a highly developed industrial society, right? So the automotive industry and the other industries that serve it constitute the backbone of the world's economy, and it will employ the greatest share of the working population, right? However, the large number of automobiles in use around the world has caused, and it continues to cause, the serious problems for the environmental and human life. What is it? It is air pollution, global warming, and the rapid depletion of Earth's petroleum resources. Okay, so these are the problems of paramount concern, right? Though we have developed it very well, but you need to understand the environmental impact. Okay, what is the environmental impact of using this modern transportation, right? So what we are ending up with, we are ending up with the air pollution, then global warming, and the last one, last but not the least, is the depletion of the petroleum resources, right? Depletion of petroleum resources. Okay, so these three are the problems of paramount concern. We must address these particular problems. Okay, these are the problems of our concern, right? So if we talk about the recent decades, okay, the research and development activities related to this transportation have emphasized the development of high efficiency, clean and safe transportation, right? So electric vehicles, hybrid electric vehicles and fuel cell vehicles have been typically proposed to replace these conventional vehicles in near future, right? So we will be talking about the problems of air pollution, gas emission causing the global warming, and petroleum resource depletion. Okay. It also gives us a brief review of the development of electric vehicles, hybrid vehicles, and fuel cell technology. Right. So the first thing we need to concern about the air pollution and why and how this air pollution is caused by the current automobile industries, right? So we will go through these air pollutions one time. Okay. So at present, if we talk about the vehicles, all the vehicles, okay, all these vehicles which are available as of now rely on the combustion of hydrocarbon fuels to derive the energy which is necessary for their propulsion, right? So combustion is there. What do you mean by combustion? If we talk about the combustion, combustion is nothing but a reaction between the fuel and the air that releases the heat, and combustion is products. Okay, so heat is converted to mechanical power by an engine, and the combustion products are released into the atmosphere, right? So a hydrocarbon is a chemical compound with molecules made up of carbon and hydrogen atoms. Okay, if we talk about the hydrocarbon, right, it is nothing but a molecule made up of carbon and hydrogen atoms, right? So ideally the combustion of hydrocarbon yields only carbon dioxide and water. Okay, whenever this thing happens, at that time what is going to produce? It will produce carbon dioxide and water, right? And frankly speaking, this carbon dioxide and water do not harm the environment at all. Okay, indeed, whatever green plants we are available with, this green plant will digest the carbon dioxide by photosynthesis, right? So carbon dioxide is necessary ingredient in vegetal life, right? Animals do not suffer from breathing this carbon dioxide unless its concentration in air is such that oxygen is almost absent, right? Whenever a small amount of oxygen is present at that time, the animals can breathe with the carbon dioxide. So carbon dioxide is not a problem at all, right? But the combustion of hydrocarbon fuel in combustion engine is never ideal. Okay, this is the ideal thing. Whenever ideal combustions will happen, at that time it will produce carbon dioxide and water, which is not harmful to the environment, right? But this is not the ideal case. Besides carbon dioxide and water, the combustion products contain a certain amount of nitrogen oxide. Okay? Now this is the prime concern. Apart from carbon dioxide and water, we will have nitrogen oxides, NOx, as well as carbon monoxide, that is CO, and hydrocarbons which are not burned. So unburned hydrocarbons will also cause a concern. Unburned hydrocarbons, that is HC. Okay, so these three are toxic to human health, right? And that is the reason why this air pollution is prime concern to us, right? So now if I talk about the nitrogen oxide, then nitrogen oxide will result from the reaction between the nitrogen in the air and the oxygen. Okay, so theoretically, nitrogen is an inert gas. However, the high temperatures and pressures in engines create favorable conditions for the formation of these nitrogen oxides. Okay, temperature is by far the most important parameter in nitrogen oxide formation. The most commonly found nitrogen oxide is nitric oxide, that is NO, although the small amount of nitrogen dioxide and traces of nitrous oxide are also present. Okay. So once released into the atmosphere, this nitric oxide reacts with the oxygen to form nitrogen dioxide, that is NO2. Okay, and this is later decomposed by the sun's ultraviolet radiation back to NO and highly reactive oxygen atoms that attack the membranes of the living cell. Okay, so nitrogen dioxide is partly responsible for the smog. Its brownish color make the smog visible. Okay, it also reacts with atmospheric water to form the nitric acid, which dilutes in the rain. And this phenomena is referred to as acid rain. That is what we know, right? We know about the acid rain. And this acid rain is responsible for the destruction of forest in industrialized countries. Okay, this acid rain also contributes to the degradation of historical monuments made of marble. For example, the Taj Mahal, right? It is turning into yellowish color, right? Because of this nitric acid, HNO3, right? So that this is the reason why these nitrogen oxides are somewhat dangerous. Talking about carbon monoxide, the carbon monoxide will result from the incomplete combustion of hydrocarbons due to lack of oxygen. Okay, it is a poison to human and animal beings that breathe it. Once carbon monoxide reaches the blood cells, it fixes to the hemoglobin in place of oxygen, thus diminishing the quantity of oxygen that reaches the organs and reducing the physical and mental abilities of affected living beings. Okay. Dizziness will be the first symptom of carbon monoxide poisoning, which can rapidly lead to the death of a person. Okay. So this carbon monoxide binds more strongly to the hemoglobin than oxygen, and the bonds are so strong that normal body functions cannot break them. Okay, persons which is intoxicated by this carbon monoxide must be treated in pressurized chambers where the pressure makes the carbon monoxide hemoglobin bonds easier to break. Okay, so this is how carbon monoxide will affect the human body. And then if I talk about the unburned hydrocarbons, then these are the result of the incomplete combustion of hydrocarbons. Okay, so depending on their nature, unburned hydrocarbons may be harmful to living beings. Some of these unburned hydrocarbons may be direct poisonous or carcinogenic chemicals such as particulates, benzene or others. Okay, so unburned hydrocarbons are also responsible for smoke. The sun's ultraviolet radiations interact with unburned hydrocarbons and NO in the atmosphere to form ozone and other products. Okay, ozone is a molecule formed of 3 oxygen atoms that we know very well, right? So it is colorless but very dangerous and poisonous as it attacks the membrane of living cells, thus causing them to age prematurely or to die. Okay, the toddlers, older people and asthmatic humans suffer greatly from the exposure to high ozone concentrations, right? Annually, deaths from high ozone peaks in polluted cities are reported. Right? So these are the three main pollutants. Apart from this, other pollutants are also there. Right? So this was the first case, that is air pollution. The second one is we are talking about the global warming, right? So we know very well what do you mean by global warming, right? It is nothing but a result of greenhouse effect which is induced by the presence of carbon dioxide and other gases, say for example methane, right, in the atmosphere. Okay, so these gases, what they will do, they will trap the sun's infrared radiation reflected by the ground and thus retaining the energy in the atmosphere. And here is the reason why the increase in temperature is observed, right? So an increased earth temperature results in major ecological damages to its ecosystem and in many natural disasters that affect the human populations, right? So this is what we have observed, the global warming, right? Now carbon dioxide is the result of the combustion of hydrocarbons and coals, right? So transportation accounts for a larger share of carbon dioxide emissions. If I talk about the emission of carbon dioxide, okay, then transportation will have a share of almost 60%. Okay, if 100% carbon dioxide is produced, then out of this 100%, 60% carbon dioxide has been produced because of the transportation, that is the vehicles, internal combustion vehicles, IC engines, right? So this is what we have been doing, right? So this is one more problem. This is the global warming, and the third one is the petroleum resources, right? Depletion of petroleum resources, right? So the vast majority of fuels used for transportation are liquid fuels which are originating from the petroleum. And what is petroleum? Petroleum is a fossil fuel resulting from the decomposition of the living matters that were imprisoned millions of years ago, right? So the process is roughly the following: living matters die and are slowly covered by sediments. Over the time, these accumulating sediments form thick layer and transform to rock. The living matters are trapped in a closed space where they encounter high pressures and temperature and slowly transform into either hydrocarbons or coal, depending on their nature. Okay? And this process took millions of years to accomplish. This is what makes the Earth's resources in fossil fuel finite. Right. So the proved reserves are those quantities that geological and engineering information indicates with reasonable certainty can be recovered in the future from the reservoirs under existing economic and operating conditions. Therefore, they do not constitute an indicator of Earth's total reserves. Right. The proved reserve as they are given in say British Petroleum, the estimate of 2001 year, are given in billion tons. Okay, right? So we will be having the oil which is extracted nowadays is the easily extractable oils that lies close to the surface in the regions where the climate does not pose major problems. Right? It is believed that far more oil lies in underneath the crust of the earth in such regions like say Siberia and the American and Canadian Arctic. In these regions, the climate and ecological concerns are major obstacles to extracting or prospecting for oil. Right? So the estimation of Earth's total reserves is a difficult task for political and technical reasons. So we don't know exactly for how much years this fossil fuel will last. Okay, so definitely there is a need to move ahead with further or say future options, right? And that is the need why we require electric vehicles to come into the picture, right? And we know that electric vehicles are not the newer one. In fact, unless and until the IC engines were introduced, public were using the electric vehicles only. Okay, so if we look back at the history of electric vehicles, then you will find that electric vehicles were found in 18th century, right? So let us look at the history of these electric vehicles, and then we'll move on to the history of hybrid electric vehicles, right? So we'll be talking about history of electric vehicles, right? So the first electric vehicle, which was built by the Frenchman Gustave Trou, Gustave Trou in 1881. Okay, and it was a tricycle. It was a tricycle which is powered by 0.1 HP DC motor. Okay, and it was fed by lead acid batteries. Okay, so this was the first electric vehicle in year 1881, which was run on 0.1 HP DC motor, and the supply was given by a lead acid batteries. Okay, so the whole vehicle and its driver was weighted approximately 160 kg. That weight of this particular vehicle was 160 kg. Okay, and a vehicle similar to this was again built by two British professors in 1883 only. Okay, so in 1883 a new vehicle was built by two professors, right? And these early realizations did not attract much attention from the public because the technology was not mature enough to compete with horse carriages, right? So talking about the speeds of 15 kilometer per hour and a range around say 16 kilometer were not exciting for the customers. Okay, whenever we talk about the speed, it was 15 kilometer per hour with a range of 16 kilometer per charge, right? And this was not economical for most of the potential customers, right? Then 1864, from Paris to Rouen race changed all the phenomena, right? It was the 1135 kilometer were run in 48 hours and 53 minutes at an average of 23.3 kilometer per hour. Okay, so whatever problems were associated with this tricycle, this was solved in 1883, right? So what they have done run 1135 kilometers in 48 hours and 53 minutes at an average speed of 23.3 kilometer per hour. Okay, so this speed was by far superior to that of possible with the horse-drawn carriages. Okay, and hence the general public became interested in horseless carriages or automobiles, as these vehicles were now called. Okay, so the following 20 years were an era during which electric vehicles competed with their gasoline counterparts. This was particularly true in America, where there were not many paved roads outside a few cities. Okay, so the limited range of electrical vehicles was not a problem. However, in Europe, the rapidly increasing number of paved roads called for extended ranges, thus favoring gasoline vehicles. Okay. So the first commercial electric vehicles was Morris and Salon's Electrobot. Okay, this was the first commercialized vehicle we were talking about. First commercial electric vehicle was Morris and Salon's Electrobot. Okay, and this vehicle was operated as a taxi in New York City by a company which is created by its inventors, right? So this Electrobot proved to be more profitable than horse cabs despite a higher purchase price. Okay, the price was this Electrobot was around 3,000 US dollars, right, which was quite high, and it could be used for 3 shifts of 4 hours with 90-minute recharging periods in between. Okay, it was powered by two 1.5 HP motors. Okay. Now it was used to 1.5 HP motors, right, that allowed a maximum speed of 32 km per hour and 40 km range per charge. Okay, so the most significant technical advance of that era was the invention of regenerative braking by a Frenchman, M01 in 1897. Right? These methods allowed recuperating the vehicle's kinetic energy while braking and recharging the batteries, which greatly enhanced the driving range. It is one of the most significant contributions to electric and hybrid electric vehicle technology, as it contributes to energy efficiency more than anything else in urban driving. Okay, we know that while we are raising the vehicle, what will happen? Whenever we have to speed up the vehicle, we will give more power to the motor. But when we have to stop, what we need to do? We need to apply braking, right? So whenever we apply brake, at that time, whatever kinetic energy is there of the vehicle, that kinetic energy will get wasted, right? But what we will do? We will recapture this kinetic energy and we will use this kinetic energy again to charge the batteries. Okay, so what will happen? The loss of energy will be reduced now. Okay, so whatever, if we talk about the recent years, then we are available with 40% efficiency of the regenerative braking. Okay, that means during braking 40% of the kinetic energy is already utilized, right? So still research are going on how to recapitulate this entire energy, how to increase the efficiency of this regenerative braking, right? So this is what happens in my 1897. The concept of regenerative braking was offered by the Frenchman Aimé Darac in 1987. In addition, among the most significant electric vehicles of that era was the first vehicle ever to reach 100 km per hour speed, and it was La Jamais Content, built by the Frenchman Camille Genarcy. Right? So here you should note that the Studbreaker and Oldsmobile first started in business by building this electric vehicle. Right? As we know, the gasoline automobile became more powerful, more flexible, and above all, easier to handle. right? Then what happens? Electric vehicles started to disappear, right? Their high cost did not help, but it is their limited driving range and performance that really impaired them versus their gasoline counterparts. The last commercially significant electric vehicles were released around 1905. Right? During nearly 60 years, the only electric vehicles sold were common golf carts and delivery vehicles. Right? Then again in 1945, the researchers at Bell Laboratories invented a device that was meant to revolutionize the world of electronics and electricity. That is the invention of transistor, right? So it quickly replaced the vacuum tubes for signal electronics, and soon the thyristors was invented, right? Which allowed the switching high currents at high voltages. And this made it possible to regulate the power fed to an electric motor without a very inefficient rheostat and allowed the running of AC motors at variable frequency. Okay. So after the invention of the transistors and thyristors, what will happen? This rheostat starts disappearing. Okay, because whatever power we were supplied in earlier electric vehicles, the variation in power was because of the rheostat. So what we were doing, we were wasting our energy in the form of heat. But now, with the advancement of these electronic devices, that problem was not there. So very highly efficient switches were available into the market. So in 1966, General Motors built the L01, which was propelled by induction motors that were fed by inverters built with the thyristors. Right? So the most significant electric vehicles of that era was the lunar roving vehicle, which the Apollo astronaut used onto the moon. Right? So the vehicle itself weighed around 209 kg and carry a payload of 490 kg. The range was around 65 kilometers, right? And the design of this extraterrestrial vehicle, however, has very little significance down on the Earth. The absence of air and the lower gravity on the moon and the low speed made it easier for engineers to reach an extended range with limited technology. Okay, so during 1960 and 1970s, concerned about the environment triggered some researchers on electric vehicles again. However, despite advances in battery technology and power electronics, their range and performance were still obstacles. Right? So the modern electric vehicle era culminated during the 1980s and early 1990s with the release of few realistic vehicles by firms such as General Motors with the EV1 and PSA with the 106 electric. Although these vehicles represented a real achievement, especially when compared with early realization. It became clear during the early 1990s that electric automobiles could never compete with gasoline automobiles for range and performance. Okay? So the reason is that batteries, the energy is stored in the metal of electrodes which weigh far more than gasoline for the same energy content. Okay. The automotive industry abandoned the electric vehicle to conduct research on hybrid electric vehicles. After a few years of development, these are far closer to the assembly lines of for mass production than electric vehicles have been ever seen. Okay, so this is the small history of electric vehicles. We have started with electric vehicles, then IC engine came into the picture. So again we turned toward the IC engines, then again we started turning toward the electric vehicles. So whatever problems were there earlier with the electric vehicles, we try to overcome these problems, such as the speed, the range. What do you mean by range? For one charge, one single charge, how many kilometers can you go with that electric vehicles? Okay, so this was about the electric vehicles, and now we were talking about the hybrid electric vehicles also, right? So what is the history of hybrid electric vehicles? This is also having some importance, right? So surprisingly, the concept of a hybrid electric vehicles is almost as old as the automobile itself. Okay, the primary purpose, however, was not so much to lower the fuel consumption, but rather to assist the IC engine to provide an acceptable level of performance. Indeed, in the early days, IC engine engineering was less advanced than electric motor engineering. Okay, so the first hybrid vehicle reported were shown at the Paris Salon in 1899. Okay, these were built by the Piper establishments of Belgium and by the Vendovely and Priestley Electric Carriage Company, France. Okay, so the Piper vehicle was a parallel hybrid with a small air-cooled gasoline engine assisted by an electric motor and lead-acid batteries. Okay, so it is reported that the batteries were charged by the engine when the vehicle coasted or was at a standstill. When the driving power required was greater than the engine rating, the electric motor provided this additional power. In addition to being one of the first hybrid vehicles and being the first parallel hybrid vehicles, the Piper was undoubtedly the first electrical starter. Right. The other hybrid vehicle which was introduced at the Paris Salon of 1899 was the first series hybrid vehicle. Okay, that was parallel hybrid vehicle, and now we are talking about series hybrid electric vehicle, and it was derived from a pure electric vehicle commercially built by the French firm Vendovely and Priestley. Okay, so this vehicle was a tricycle, right, with the two rear wheels powered by independent motor and an additional 3 by 4 HP gasoline engine coupled to say some 1.1 kilowatt generator was mounted on a trailer and could be towed behind the vehicle to extend its range by recharging the battery. Okay, so in the French case, the hybrid design was used to extend the range of an electric vehicle and not to supply this additional power to weak the internal combustion engine. Okay, so this Camille Genatzi, which present a parallel hybrid vehicle at the Paris Salon in 1903. Now, this vehicle combined a 6 HP gasoline engine with 14 HP electric machine that could either charge the batteries from the engine or assist them later. Okay, then another Frenchman who built the second reported series hybrid vehicle in 1902, his design used two independent DC motor driving the front wheels. Right? They drew their energy from lead acid cells that were recharged by a 4.5 HP alcohol spark ignited engine coupled to a shunt DC generator. Okay, so this is the way how hybrid electric vehicles comes into the picture, right? So other hybrid vehicles, both of parallel and series type, were built during a long period ranging from say 1899 until 1914. Although electric braking has been used in these early designs, there is no mention of regenerative braking, right? It is likely that most possibly even all design used dynamic braking by short circuiting or by placing a resistance in the armature of the traction motors, right? So what will happen? All the energy will get lost. Okay, so whatever hybrid electric vehicles were reported during this particular era, they were using the dynamic braking, which is not efficient at all. Okay, so this Early hybrid vehicles were built in order to assist the weak internal combustion engines of that time or to improve the range of electric vehicles. Okay, they made use of say basic electric technology that were then available. In spite of the great creativity that presided in their design, these early hybrid electric vehicles could no longer compete with the greatly improved gasoline engines that came into use after World War One. Okay, so the gasoline engine made tremendous improvements in terms of power density. The engine became smaller as well as more efficient, and there was no longer a need to assist them with electric motors. Right, the supplementary cost of having an electric motor and the hazards associated with the lead acid batteries were key factors in disappearance of hybrid vehicles from the market after this World War One. Right, so hybrid vehicles were also obsolete now. Only the gasoline vehicles were available into the market. Right, then we will be talking about the fuel cell vehicles. Okay, so let us go through a brief history of fuel cell vehicles, right? So, as early as say in 1839, Sir William Grew, which was also known as the father of fuel cell, okay, in 1839, Sir William Grew, which was known as the father of fuel cell, he discovered that it might be possible to generate electricity by reversing the electrolysis of water. Okay. It was not until 1989 that two researchers, Charles Langer and Ludwig Mond, coined the term fuel cell. Okay, as they were trying to engineer the first practical fuel cell using air and coal gas. Okay. While further attempts were made in the early 1900s to develop this fuel cell that could convert coal or carbon into electricity. The advent of the internal combustion engines temporarily quashed any hopes of further development of the fledgling technology. Okay. So the Francis Bacon developed what was perhaps the first successful device in 1932. Okay, with a hydrogen oxygen cell using alkaline electrolytes and nickel electrodes, inexpensive alternatives to the catalyst used by Mond and Langer. Okay, so due to a substantial number of technical hurdles, it was not until 1959 that Bacon and Company first demonstrated a practical 5 kilowatt fuel cell system. Okay, so Harry Carl represented his famous 20 horsepower fuel cell power tractor the same year. Okay, and NASA also began building compact electric generator for use on space missions in late 1950s. Okay, NASA soon came to find the hundreds of research contracts involving fuel cell technology. Fuel cells now have a proven role in space programs after supplying electricity to several space missions. Okay, so in more recent decades, a number of manufacturers, including major automakers and various federal agencies, have supported ongoing research into the development of this fuel cell technology for use in fuel cell vehicles and other applications. Hydrogen production, storage, and distributions are the biggest challenges. Truly, these fuel cell powered vehicles still have a long way to go before they can be introduced into the market. Right? So, talking about the latest inventions and latest research trends, the electric vehicles, hybrid electric vehicles, and fuel cells are the hot topics. Right? So this was about the history of the transportation, how we have started with the electric vehicle, then how we move to the gasoline. Again we started with the hybrid electric vehicle, but again we moved to the gasoline vehicle, and now in today's era we have been started with the again we have started with the electric vehicles. Lots of companies, lots of automobile companies are doing their research on electric vehicles, on building a better efficient electric vehicles. Some companies are working on battery management system, some companies are working on battery itself, some companies are working on different kinds of drive motors. Okay, so which is the best suited for a particular machine. Okay, so in this particular course we will begin with the fundamentals of electric vehicle, right? What are the different resistance offered to us, right? Whenever a vehicle has to make a move, definitely resistance will be there, which is an aerodynamic drag or a rolling resistance or a grading resistance, etc., right? So as a first move into the electric vehicle, we will start with the general descriptions of vehicle movement. Then we will see some vehicle resistance, what kind of vehicle resistance we are available with. Then we will try to drag the dynamic equations of these electric vehicles, right? So this will be our first step, the motion and dynamic equations of electric vehicles. Then we will see the various forces acting on the vehicle in static and dynamic conditions, right? So we shall stop for today now, and in the next lecture we will start with our actual content of the course, which is vehicle fundamentals. So we will see some basic equations of this vehicle, right? And then we will move on to the further topics. Okay, so we shall stop here. If you have any question, then you may ask.